There's relatively poor control of vitamin D from many manufacturers, and that's because the Food and Drug Administration regulates all vitamins as foods. So there's about the same control over vitamin D as there is over broccoli. And the same standards are pretty much applied under the circumstances. So you've got to find one that does the job for you and stick to it. And brand name accountability is still something I think you need to rely on. I mean, I can't specifically promote any particular one, but this is still I mean, if you recall browsing the vitamin shelves of grocery or drugstores as recently as 3 years ago, you had a hole in the alphabet. There was A and B and C, and you skipped to E. There wasn't any D there at all, except as a kind of ride along in the multivitamin capsules where you had some. So we've got a brand new market, and it's still not up to uniform standards, but it's going to get there.
My question is, how long does D3 get stored in the body? And for absorption, can you take all 10,000 IU in the morning, or do you need to spread that out throughout the entire day?
Two very good questions. How long is vitamin D stored depends upon how much you're taking. If you need 4,000 international units per day in order to maintain a blood level of 32 nanograms per milliliter, as we've shown unequivocally you do, then you don't store any at all because you're using that 4,000 every day. You only store it if you're taking in more than you're actually consuming. And you begin to see that when you get above 5,000, 6,000 international units per day. Then the storage begins to go up. But I mean, as obvious and important a question as you've just asked, there have been almost no data on it. We have a paper in press right now showing the vitamin D content of fat biopsies. We got a batch of people who agreed to let us take a piece of their belly fat and to get the vitamin D measured in it. But I have to tell you, there has never been a publication of human fat vitamin D content in normal individuals. It's never been done. And that's why we've got such bad information about precisely the question you asked about how long. Now, can you take it all at once? Well, I don't know that you need to take 10,000 international units a day, but if you did, it wouldn't hurt. That's a safe upper level. And it doesn't make a difference whether you take it all at once or not. The half-life of vitamin D in the body is fairly long. And we find that compliance is often better if you take it, say, once a week, where it's easier to remember. You take it on Sunday morning, for instance. Well, if you wanted to take 4,000 international units a day, well, on Sunday you'd take 30,000. That's 7 times 4, basically. That works perfectly well. It's perfectly safe, and it's convenient. You can stretch it out even farther, say for individuals in nursing homes where adding 1 extra pill a day can be an insuperable barrier sometimes. So you can do that even as infrequently as once a month, and you can still get good vitamin D control. But I wouldn't stretch it out any farther than that. Many of the studies that I've shown you data on used different dosing schedules, but they didn't know how long the stuff lasted, and because it hadn't been measured. It's one of the things we've been trying to do here at Creighton. We've been measuring all those kind of roadmap issues of how long, how much, where does it go, and so forth. We still have more questions to ask and to answer.
After you change a dosage, how long does it take to get to a steady state?
5 months.
5 months.
But most of the change occurs fairly rapidly. But I mean, you said to get to a steady state, it takes about 5 months.
Okay, then what do you advise for infants and children?
Well, I'm sure I'm sure the rise time to steady state is much shorter there. It's not been measured.
Or just dosage-wise.
75 units per kilo. That's a number that fits everybody from 6-month-old infants to 50-year-old morbidly obese women at a BMI of 50 kilograms per meter squared. I mean, that dose is one size fits all, but basically it's not one size because you're using different doses. But it's a formula that fits everybody.
Other questions?
Dr. Sorensen said that this time of the year you don't get any vitamin D from the sun.
I assume that you're only talking about 2 or 3 months in the summer where you get optimum vitamin D from the sun.
That assumption is correct. It's a function of latitude. Once you get below the latitude of Dallas, you don't get any UVB in the wintertime at all. You could probably get some at noon on Christmas Day in Dallas if you're outdoors with no clothes on, but not much. The closer you get to the equator, the more you're going to get.
We have another question here.
This is about tanning beds. I was under the impression that most tanning beds use primarily UVA rays, and it's my understanding that UVB is what we need to produce vitamin D in the skin. Is this inaccurate, or?
UVB is the wavelength that converts 7-dehydrocholesterol to pre-vitamin D. UVA does not.
About
So-
90% of tanning units emit UVB and UVA in levels that are consistent with sun.
There was a question here.
This you talk about cancer and vitamin D, and you kind of touched on the mechanism a little bit in terms of vitamin D giving a signal to the DNA. Can you go into that in more detail? For instance, if you have breast cancer, for instance, typically there's suppressor genes that are suppressing cancer. Your body's constantly going through suppressive mechanisms to prevent cancer. How does that actually occur with vitamin D?
Well, to take the example that you just cited, if you need to activate those suppressor genes in order to control the possible development of cancer, and if you need vitamin D to open up those genes and you don't have vitamin D, therefore you can't suppress the cancer.
Is there like a lock and key that vitamin D definitely
No.
activates that gene?
No, there is not a single lock and key. It is a part of the mechanism, and different tissues have more or less redundancy. And some are, but they're all impaired if you don't have enough vitamin D. Now, there are several levels at which this cancer story works. One is that vitamin D is necessary for the expression of the genes that lead to apoptosis, which is controlled cell death. Our tissues are turning over all the time, and when the cell doesn't work anymore, the body tries to get rid of it. So it has a controlled death package, which deconstructs that cell safely so that its constituents don't get out and cause other damage at the same time. If that program doesn't work, then that cell can become a rogue cell, and that's where you begin to get some sort of cancer formation. And then at a little bit later stage, after you've got some of those bad cells, they are still stuck to one another. And as long as they're stuck to one another, they don't do a lot of damage. But the proteins that hold cells together, called cadherins, are dependent upon vitamin D. If you have vitamin D deficiency, you can't produce the proteins that keeps the cells sticking together. So they wander off, and that's how you begin to get what we call in the cancer field metastasis. They spread to other parts of the body. So at every single step, I mean, we know cancer is typically a 10 or 12 step process. You got to have this go wrong, then you got to have that go wrong, then you got to have the other thing go wrong. And if vitamin D is necessary for each of those steps, then you see you've got different chances to produce the ultimate outcome. And I don't think we begin to know what all those steps are. It's only been 2 or 3 years ago that we had any recognition that cells could make their own active form of vitamin D, and that they used it locally precisely to control this. So I mean, there are new papers every week showing another action of vitamin D in these systems. I'm speaking only very generically and not highly specifically, as you recognize.
We have one more question, but before I get to the question, I want to thank our speakers once again for some excellent presentations today.
I was curious on what we could do for, I have several patients in my practice that are vegans, and other than using tanning beds or the natural sun source, what would be something? I know that Dr. Sorensen mentioned that vitamin D2 was not as efficient as D3. What would be something else that they could do?
Well, they need to take D3. It's what they would produce in their own skins. So, I mean, it all depends on how rigidly vegan they are. If they will stay away from anything that ever touched an animal, then they can't use the commercial vitamin D3 preparations. And you can use vitamin D2, and it works, but you have to give more of it. You have to give it more often. The high-dose vitamin D2 preparations are prescription products, and so there's an extra cost associated right there. But it'll work for them. Tanning beds will give them the natural vitamin D, but that can be expensive too. You know, vitamin D3 is cheap, and that's one of the reasons why there's no commercial push for it. And that's why we need grassroots pushing.
Well, thank you very much, Dr. Haney, Dr. Sorensen, and Carol Baggerly.